it says start, and now I can move my OBS out of the way, and I can go and I can play videos like this.
To zoom over what's at.
Or I can record myself saying, "Hey everybody, look, I'm going into Blender," and I think you're seeing it. Let me pull my thing up so I can see what it's. Yeah, so you should be seeing my Blender screen, and I don't have a video capture device working. Why? Probably because. Yeah, because I'm using my video for Zoom. There we go. So do you see me at the bottom right corner?
Mm-hmm.
And you see the Blender screen, right?
Yes.
All right, so I'm recording this video, and I would be going, "Hey everybody, I'm going to start working with Blender GIS, and here it is up in the right side of the screen. If you don't have Blender GIS, I will tell you, go to the web and go for, and you don't have to do this now, Blender GIS, and then you'll find a link, and then you will download the zip file, and then once it's downloaded, you will go into Blender." I hope you're seeing all this. Tell me if you're not. You are seeing it?
Yep.
Okay.
Mm-hmm.
You would go to Edit, and you would go to Preferences, and you would go up to Get Extensions, and you would tell it that you want to go to Repositories, and then find where we have downloaded it, or I can search for extensions. Anyway, I'm just doing this just to show you how OBS works, not to show you Blender. And then I have an add-on called Blender GIS, and I toggle it on, and then I go through these procedures to tell it where to store stuff. This is all sort of stuff I would go through. It's setup stuff. And once it's set up, then bang, I have GIS that appears here. And then I go to Web Geodata, and I say, "Hey, I want a base map from Google Satellite." And I say, "Okay," and a map appears, yay. And then I say, "Go to" by hitting G, and I'm going to put the zoom level at 20. And then I want to go to let's go to Gamble Creek Farm. Maybe it's on here, maybe it's not. So I say, "Okay." And it doesn't know Gamble Creek Farm. Can we use your address, Mary?
Sure. 402
402
San, S-A-N, Salvador Drive, Dunedin.
Dunedin. Okay, and then Florida. And let me change the zoom level and say okay. And it's downloading some tiles. There's your house.
Hey.
Is that your house there?
That's an old picture of my house.
Mm-hmm. Which one? The one on the top or the one with the solar panels?
Nope, this one I think. Yeah, it's a corner. Yep, that one.
On the corner?
Yeah, that's at least 7 years old.
Okay. So now I can say I want to get that landscape to see the flooding potential. I zoomed out a little bit more. I hit E for extent, and I have a plane that has a picture of your house on it. Hey, that's nice, isn't that fun? Now I go to GIS again, and I say get elevation from the satellite topographic mission, from the radar, satellite radar topographic mission, 30-meter resolution. But I need an API key. So then I say, "Okay, everybody, we need an API key for Blender GIS from Open Topography." And yes, if you had to do this by memory, you'd go crazy, but I'd be taking you through it and you'd be following step by step how you go here, how you go to request an API key, how you have to enter in your email and password. So don't get overwhelmed. Just know that obviously video will show the actual steps if I was doing it slower. But this is just an overview. So you get the API key and you come back into Blender and you paste the API key in and say OK. And then it links you to the satellite data, and we wait for a few seconds while it downloads the satellite data, and we pray that nothing goes wrong, which is okay. And then we go, oh, look, there's satellite data. Now, do you see it? No, because you're in Florida where things are really flat. But you see there's curvature now?
Mm-hmm.
So that's sort of nice. It's not perfect because it is satellite data, but if I go to the strength, this is what Dunedin actually looks like around your house from water's perspective. You
From
see
water
that?
perspective? Okay.
Yeah, like water's going to seek the lowest point.
Okay.
So if you want to know where the flooding is going to go and where your house is relative to that flooding,
Interesting.
your house is right there in the valley. Not the deepest, not like this neighbor here.
I know, but that's funny because, so wait a second. So does it show, here, can you make it bigger? Again, can you bring it forward more? Okay. So where is my house?
I thought it's this one on the corner, you said. Because there's the guys with the solar panels.
Okay, so this one now, that's interesting because does it show where the Pinellas, so Pinellas Trail, which was a train track, we are a block off of that. And so my neighbor here, okay, so this is me, here's my neighbor, and this maybe is a Pinellas.
I can't see what you're referring to, but...
Oh, okay. So, can you see my mouse?
No.
No, okay.
Well, maybe I can go to Zoom and see. No, because I'm doing the screen sharing.
Yeah, okay. So the house to the left of me across that street, that one.
Okay.
Then to the left of that, see where there's that.
Yeah, there's a bike trail here.
That's the Pinellas Trail. Those were train tracks. Those are supposed to be at 19 feet. So that's supposed to be one of the highest points because the train tracks were elevated, you know? And
well, it's not as high as this neighbor here where these trees are, but this is a gross exaggeration of the landscape. And if I bring it back to what it's normally at and bring the strength down to 1, this is actually how it appears. And you're right, if I look at it in relief, that train track is higher than these houses over here.
How can you see that? Or maybe just so small for me, I can't see it. But
yeah, I mean, I'm looking at a sort of bend or a curvature, and that's why I can start doing this bending here. And you'll see the train track is lifting up.
Where? Okay, can you point to where the train track? Okay, there's it. Okay, so can you put it at the angle where I would be able to tell that it's lifting up? Well, yeah, it's lifting up in one area, but then it's kind of...
Yeah, it's uneven topography, and that's the beauty. When the satellites take this image, they're bouncing radar signals off the ground, and then by the time it takes to get back to the satellite, or in this case, it was the space shuttle doing it. So the astronauts flew around the Earth over and over and over, and they kept taking radar measurements of the surface of the Earth. This is going back to the 90s, this data set. And they were doing it at 30-meter resolution, so it's not accurate below 30 meters. But with a 30-meter resolution, as they scanned these areas, this area down here where the crossing is lower than this area where the trees are. And I can exaggerate it further to really give you what water would see. And this is not what you're going to experience when you're on the landscape. But look at how up here, yes, the train tracks are on a hill.
Yeah, but to the left of it. So if you go to the left and you look at to the left of it, like that hill there.
Yeah.
Oh, that's alt 19.
Uh-huh.
19 and major. Okay, so just after alt 19, then would be the highest part.
Yeah. I mean, according to this exaggeration of this low resolution 30-meter data, now they have satellites that you have to pay for. I can't get them for free in Blender, but you'd pay for them and they go down to 1 centimeter.
So what does that mean, like when you say 30 meters?
It means that there's a square, like every time that you look at the data here, you see those squares up behind it?
Yeah.
Those squares are set to 30 meters, which is basically, I think we're looking at, maybe William can correct me if I'm wrong, it's either, I mean, it could be 10 by 3, which would be a yard by 3 yards, or it would be probably more likely to be, I can't divide 30 by, what's the square root of 30? It's 3, 4, 5. It's between 5 and 6 feet by 5 and 6, 5 and 6 meters by 5 and 6 meters. So 2 yards by 2 yards is the square that it bounced. Like the radar, when it hit the ground, imagine it was beaming down in a 2-yard by 2-yard square and bouncing back up. So it couldn't capture any of the detail inside your yard. Like if you have a little permaculture mound or a hugelkultur you built, that radar would never have captured it. So the square that it's beaming down, like let me show you.
So you don't know where it's beaming down, on what square?
Right, I don't know. Like if I do if I add a cube to this, this is a 1 meter by 1 meter cube. And I just said it would be 5 meters by 5 meters is roughly 30 meters square. So I need to bring this up to, in size, I need to scale it by, oh, that's a 2 meter square. Okay, so if I go up to 5, 5, 5, that's what was beaming down. And so whenever this radar went boom and went back up, boom and went back up, and then
so it's showing you where that line just was?
Yeah.
Is that where it's showing you where that it was measuring? Like how do you know where it's measuring actually? Like where that line is?
We don't know. I'm making an animation that is false animation saying, imagine that the satellite passed by and it sent down this radar pulse this big as this square, and it hit the ground and then went back up. And then it went over this way and it went down and hit that square and went back up. And then it went over this way and it went back down and bounced back up, right? So every time it bounced up off a hill, it took less time to get back to the shuttle than when it went over this valley part here. And then it took longer to get up. And so the satellite says, okay, this is deeper.
Yeah. That's how it's measuring.
Right. It's like it's smacking the ground
like echolocation or something?
It is echolocation. That's exactly what radar is, except instead of using sonar, which is sound waves, it's using light waves.
Okay.
Yeah. So that's a really good analogy. So it's like a bat or a dolphin.
Yeah.
And it's just beaming down like bing, bing, bing. And that's how it's developing this model. And then I'm really exaggerating the model. But it's really subtle in Florida. I mean, if you were in the mountains, you'd see it really obvious. But that does give us the possibility to look at flooding. And one thing I'm going to add to this model, let me go back into the bird's eye view. I'm going to add buildings from OpenStreetMap, which is open source. And I'll go to building and do the elevation from the object, which is the satellite image. And now you see all those buildings. So your house is one of these. See how I was just able to get those buildings in? And they're tagged to the elevation. So when should have been, but I didn't apply it. Okay, so can't do that until I know what I know what I did. I'm not able to exaggerate beyond the reality because the buildings are tied to the reality. If I start exaggerating the map, it's going to go all warpy without the buildings.
So, okay, so if we don't know where the satellite is actually pinging, right? We're measuring. We know it's a small area. And it's basing. So when you type in my address, it's just pinging some area of land on that address.
Well, it did it in the 1990s. So it's not actively pinging. I'm calling on old data.
So this is as if there were no changes since the 1990s.
Yeah, right.
But there could have been changes since the 1990s.
Right. So the professionals use the latest satellite data. The Europeans have released a lot of it for free, and I'm beginning to add those to my QGIS models so I can use much higher resolution, more up-to-date data. But what they give the general public is this.
From 30 years ago.
Yeah. And assuming the mountains haven't changed that much. I mean, really, the Himalayas aren't that different. Florida, but Florida's elevation hasn't changed. What's changed is sea level.
Right.
And that's why Florida's going under. It'd be nice if Florida rose along with the sea level.
Right.
It ain't. So so if we go back again to GIS and go to base map, just so you can see the procedure again. And then I'm in here, but now if I zoom out, I can get your house in relation to the ocean.
Right.
It's a much larger map. Now it takes more data. Then when I hit extent, I have this map. And if I take this map and I go to my WebGeoData, get elevation, and bring it in, you should show up that you're higher than sea level.
Yes.
Because otherwise you'd be underwater. So let's wait for this to come in. All right, so there's the map with sea level. And look when I exaggerate that. See that? So this is Dunedin.
Mm-hmm.
But that's an exaggeration to look at all the little details at 30 meters.
Right.
And of course, sea level ain't going to rise because sea level, according to the shuttle, is flat. So nothing I do is going to exaggerate sea level. Right?
Mm-hmm.
So now, when I bring it back to a strength of 1, and I go in and I bring in my buildings. So let me build in oops, not that. Let me go to GIS, WebGeoData, get OSM for OpenStreetMap, bring in buildings from elevation from that object, and then I'm going to make them a little smaller because this always defaults to make skyscrapers, and we don't want that. So this is not accurate. You'd have to know what the average height of a building in Dunedin is, and then put that in here. But we'll keep that. When I bring in the buildings, oh, it's, you know what it's telling me? It's saying that I picked a map that's too big. It doesn't like that. And that's why ultimately I use QGIS with Blender instead of just relying on Blender. Let me go and make a smaller map for you. Delete. Let me go to GIS, go to base map, and bring it in. And let me zoom in. It's probably not going to let me right now with this procedure get your house and the beach. So let's just look at the beach. And let's find a place. I guess those piers down by your house would be interesting, right?
Some are and some are okay. Some were taken out and some,
So do you recognize any of this parking lot or this shopping mall?
Here, can you put your mouse on where this?
Well, this blue building over here by these trails.
Those are homes.
They are? Because what I often do when I want to ground truth this, I go to maps.google.com and then I put in, what's your address again?
402.
402.
San Salvador Drive.
Salvador, there it is. Okay. So I'll go to this map, and then you have a pin on it, and I see you're near Kiwanis Park. Okay, so then when I go back to my Blender, you're down near this lake somewhere.
Mm-hmm.
You're above Hibiscus Lane. So you're up in this region. So let me see if I can focus in here. That might include your house. I think this is your house right here. That one there, maybe? That one there. All right. Let's see if this will capture without using QGIS. I'll just use Blender GIS for now. So I'm going to try to get the satellite image. The procedure is always the same. You start with a texture of an area of a plane, then you get the satellite imagery to get your digital elevation. There, it came in, and then I go to OSM building, and let's see if it brings in those buildings without crashing. Okay, they came in. So your house is there. All right. Now, once again, if you look at your house's elevation, you're obviously higher than the coast directly. Right?
Mm-hmm.
But what we do when we want to see sea level rise, I'll also bring in streets. So give me a second to bring in OSM and bring in the highways. And let's go that in there. Oh, that it wants to know a query thing. So go to WebGeoData, get OSM, take the highway, and say OK. All right, there's the streets. Right? And even now there's a database for this. When I look at the Waze highway here, you can see Alamo Lane, Hibiscus Lane, Pasadena Drive, Rowena. I wonder if yours will show up in here. It's San what?
Salvador?
San Salvador. No. Oh, there it is, San Salvador Drive. Okay. So it's there. I need to zoom in on it. And that's the whole thing. San Salvador. It's not letting me isolate it. It's obviously in the data set, but I'd have to, there it is. All right. So if I click off of that and I just pick San Salvador, it's the whole thing. It's, I haven't separated out the streets. So that's another procedure I don't want to get into right now. There's a way to separate out the streets and label them and then find San Salvador Drive. But I think San Salvador Drive, according to this, is this street right here. Yeah. But then you want to see if the streets will flood, and there's techniques to make the streets wider. These are just lines for right now. But then what you do is you'd say, all right, I want to see where the sea level rise would affect. And so what I do is I'm going to save this, by the way. Save as Dunedin 42, what was it, 4202 or 402?
402.
San Salvador. And I'll save that file as that so I don't lose my work. Okay, so then you come in here and you say, all right, I want to add a plane. And I'm going to make that plane really, really big. All right. So there's the plane. And I'm going to color that plane blue so I know that it's water. So make ocean water of it. All right. And now that's sea level. And your home is somewhere in here. And if I take that sea level and I start to move it up, you see who's going to get flooded first.
Okay. Wow.
Right? So your neighbors, I would head to these people up here.
Good to know. Yeah, they are higher. So they're, now I'm thinking of that neighborhood. They are actually up on a hill.
Yeah. And
they would definitely be, I don't think of them as part of our neighborhood because they're set back in like a development.
Yeah.
But yeah, they are built higher.
And you said you're how many meters above the ground?
Well, I'm supposed to be, so the property is at 16 feet. Then our house is raised another couple feet, or 2.5, 3 feet. So like say 18, 19 feet to my front door. But the property.
This blue level in the z-axis is now 15 feet, 60, or 6 times 3. This is 18 or 19 feet, and your house is still okay.
That's that's water coming over.
Yeah. Now as I raise it up a little more, I'm at 7 meters, 8 meters, 9 meters, which is about 30 feet. Now you're under.
Yeah, well, I would imagine. But where? So can you do that again? Like, where? At what point here do we really have to start heading to the back of the neighborhood?
So where's your house again?
Is it 20 feet?
Let me turn off the buildings.
So that's all linked.
Yeah, I'm gonna turn off the buildings. Clicking on this eye here. Try to find your house again. I think it's.
So it would.
There it is, right here.
Okay.
Yeah, and let me turn on the buildings again. Where's my buildings? There it is. If it is this one, is that the one it is?
Yeah, I think it's that one. Yeah.
Okay, so what I have to do is I have to go into Edit and find your building alone, and then select it. It's this one here. Oops, I forgot part of the other building. My mistake. Okay. Now I'm going to separate that with Alt-P. Alt-P? Or is it just P? There. Separate by selection. And now I can name that building. Let's see if I can. It's that one there. I'm going to name that 402 San Salvador. And now go back to my view here and turn off editing. Now get these guys and hide them. So that's just your building now.
Right.
And if we calculated the actual height, and I haven't done that, but if I were to say, okay, the scale or the location or the dimension, if we knew that your building was, 6 meters, then it would be like that. Although it's not sitting on the landscape, so let me move that. So there's your cars, right? So that way you could know where your roof height is to know if your second floor is safe.
Mm-hmm.
Right? So that is your building. There's the ocean. And then I grab my layer of ocean water, knowing that I need to make your building visible. So let me put a color to your building. What color do you want for your building?
Red. Okay.
There you go. So now it's really easy to see your building. And I would take this sea level and I would say, all right, I want to move this sea level up and make it, let's see, they say there's going to be a storm surge of
Like 20 feet.
20 feet, which is basically 6 meters.
Okay.
All right, you're okay.
Okay. Jeez. But that's
Well,
not,
but that's not encouraging the wind that's blowing it in.
well, because I was going to say that's not accurate because these houses are just not good. I mean, they
No,
are done.
and I don't mean to be misleading. This is sea level rise. Storm surge is a wind of a hurricane at 120, 130 miles an hour, pushing water at 6 meters up the landscape.
Right.
Which would be, imagine instead of this being flat, if it was, let me see if I can do this, rotate, that's this.
Mm-hmm.
Right, that's this thing coming in and like a wave coming through and going.
Right.
And
So
then
this can't give you like a simulated like hurricane at say 90-mile-an-hour wind. What that 6 meter.
oh, Blender alone can't, but Blender with QGIS and the processing tools, the geoprocessing tools, absolutely.
Okay.
Sure.
Because that's really how if you were really looking at like a neighborhood, okay, so there's a category 2 or 3 hurricane coming that we know the winds are between 80 and 110 miles an hour.
Yeah, absolutely. And that's the thing about this. What did I need to go back again? Let's see. All right, so sea level is technically 0 meters. That's sea level, and you can see that there's a tidal thing going on. So at absolute sea level, these piers are not inundated with water, according to this map. But as if you say, what's my home going to be like when the sea level rises by the estimated, I don't know, by the end of the century what it's supposed to be, but let's say that it's supposed to rise by 1 meter, right? Your home is still okay. These guys aren't. But over time, if it keeps going, and some people have said it can get as high. Let me just check it. I'm going to speak out of turn. Let me go and ask, what is sea level predicted to be in Florida in 2100? Two to 8 feet. So it's only 1.5 meters. 2060, it'll be 1 meter higher. But this is at current rates of warming, which is accelerating all the time. And it says 900,000 properties will be at risk of being underwater in 2100. And that's without storms. And we're just talking about sea level rise.
Yeah.
So this is more like what you're going to experience, 1 meter to 2 meters. That is going to eat up the coast there. The storm surge will be correspondingly higher. And it looks like when your house goes under is when we get up to, you start getting hit when we get up to 9 meters or 20 or 30 feet.
Right. But that's not to say what that would be storm surge.
Oh my gosh, no, storm surge are gone.
That's when you have to worry about.
Yeah, this is Tuvalu. I mean, then these other islands that are below they're at sea level, or in some cases with atolls around them, there are places on the island that are below, and you can see when the water is pooling. Denmark is a good example. Holland. I mean, they've had to put dikes around the entire country because the country is called the Netherlands, the lands below the sea.
Yeah.
And they're terrified. They have to put these seawalls and stuff.
Mm.
But storm surge would be a more complex calculation, which would involve tilting and simulating. And we can do it, and I'll work on it. I have to watch another tutorial. I've done it once last year in the envisioning class. We our student Aaron wanted to see how his mother's backyard would do, and we did a fluid simulation, and we had the waves coming right in.
Yeah.
Because here in Blender, there's this thing called physics, and you can do fluids, and then you can tell it how to make the flow, and then you can run the simulation. And that's why I was saying in class, it's inexcusable that North Carolina or Tennessee had this catastrophic flooding, because any 8-year-old with Blender and QGIS can do this. I mean, this ain't rocket science.
Yeah, it's just knowing how to. Yeah. It's just knowing how to download it. First of all, that's the first step. That wasn't exactly
right.
And now challenges.
Now look what happens when I hit stop recording.